Hey boys and girls, so today I'm super excited because we're going to be talking about fractions. This just makes my former fourth grade teacher heart happy. You guys have been working a lot with fractions and you started really in third grade, you did a lot in fourth grade, you touched on it again in fifth, and now we're going to combine all that knowledge and take what we know to really dig deep in sixth grade. Today, we're going to talk about multiplying fractions. Not how you multiplied fractions by whole numbers in the fourth grade, but in sixth grade, we're going to multiply a fraction by another fraction. But first, I need a little water. Shout out to Starbucks. This is my limited edition mermaid cup. You know, both my little brothers work at Starbucks. And you see that it is about 1/3 of the way full, 1/3. And let's say that I just drank 1/4 of that 1/3. So let me write that down. It was 1/3 of the way full. And I just drank 1/4 of that 1/3. So what if I want to find out how much water did I just drink? That's a good question. So I'm going to use an area model. Let's do a model. Let's start off with a picture. And I'm going to do this whole rectangle would be equal to 1 full bottle of water. So I have we started off with 1/3. So I'm going to split this, partition this. Partition means when you're splitting or separating something. So I'm partitioning this model into thirds. I started off with 1/3 of the water bottle full. So I'm going to shade in 1/3 of this area model to represent what I started off with, the 1/3. We good? Gucci? Okay. So then I drink 1/4 of that 1/3. So I'm going to take these thirds, the whole water bottle, and I'm going to partition it into fourths. So I'll go, instead of vertically, I'm going to go horizontally and partition these thirds into fourths. So I just did it into halves. And again, I just did it into fourths. So now, if you're just looking at the red section, for example, instead of 1/3 now, it is actually split into 1, 2, 3, 4 equal pieces. So if I just drank 1/4 of that 1/3, I'm going to highlight one of those fourths of the 1/3. And now you see it's kind of a yucky purple color, but we'll roll with it. So what does the purple, the yucky purple color, we'll call it purple, it's kind of messy. What is this purple shaded portion of the area model showing you in a fraction? So let's find out together. We should know this, but let's just make sure. So our denominator, let's find out what our denominator is first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible pieces in this area model. The purple only has one shaded. So the purple shaded part shows 1/12 of the entire model. So 1/4 of 1/3 equals 1/12. So now that we've solved this using an area model, what do you guys think? How effective is using an area model? On your test, are you going to have time to draw pictures for all these questions? Probably not. So let's use this conceptual understanding that we've just built and introduce a procedural version, if you will. So when we multiply fractions, what we're really doing, a fraction by another fraction, is we are multiplying the numerator by the numerator, so 1 times 1 in this instance, and the denominator by the denominator, so 4 times 3. So 1 times 1 does give us 1, and 4 times 3 does give us 12. That is why the area model, that is why the math makes sense when we do it procedurally like this, when we multiply numerator by numerator and denominator by denominator. That's why this makes sense. So we got the same answer. Our strategies are comparable in that they're getting us the same answer, but this is definitely the more effective way to go. Let's try one more example before we take it up a notch. Go ahead and try this one out. Try this one out. All right, so you should have multiplied 3 times 2 in your numerator and 6 times 4 in the denominator to have gotten 6/24. Good? Awesome. Maybe you simplified it, maybe you didn't. But either way, as long as we got to 6/24, we understand this strategy, so we're good to move on. So let's try a different type of problem. Let's say that you're looking at something like this on your quiz. Hint, hint, you might be. Three sevenths times 1 something equals 3/28. Can you infer the missing digit? So we know that 3 times 1 equals 3, and 7 times what equals 28? Good job. So you should have gotten 4. 7 times 4 gets us to 28. So the missing digit would be 4. Woohoo, if you got that right. Awesome. Okay, now let's take it up another level. So you're not always going to have to just multiply a fraction by a fraction. Sometimes you're going to have to multiply a mixed number by another mixed number. So let's take a look at what that might look like. Let's say that we have 1 and 4/5, 1 and 4/5, that's our mixed number, times 3 and 2/3. What are you thinking right now? What's going through your head? How can I possibly multiply this? So if you said that, oh, that's so easy, Miss Morris. Are you kidding? Obviously, 1 times 3 is 3, and 5 times 3 in the denominator is 15, and 4 times 2, I mean, duh, it's 8. Not that easy, guys. That's not gonna check out. So what we're gonna need to do is we are going to need to use our 4th grade knowledge of converting mixed numbers into fractions greater than 1. AKA, your teacher might have called them improper fractions, but there's nothing improper or wrong about them. The numerator is just bigger than the denominator, so let's try it out. Let's say we have 1 and 4/5, and we're trying to convert that mixed number into a fraction greater than 1 so that we can do our multiplication and move on with our merry day. Go ahead and try that out right now. I want to see if we're rusty or if we're good to go. Okay, so you know that 1 and 4/5, it can be decomposed or split up into 1 and 4/5. We can show that 1 as 5/5. When we add these two pieces back together, we get 9/5. So 1 and 4/5 is the same thing as 9/5. fifths. Is writing that out always going to be the most effective strategy, especially when you're dealing with larger whole numbers? No. So I'm going to show you another strategy that your basic understanding of this math can help you make it more effective. And it's kind of like a trick. I don't really teach tricks. I teach you the math and why it makes sense. And then like, if you want to use a trick, that's fine. But as long as you're able to understand and get that, then you're good. So 1 4/5, here's my little trick. As long as you understand why it works, you can use it. My little trick, when I first started teaching this, that Drake song, Started from the Bottom, was really popular. So I said, all right, guys, you're just going to multiply the whole number by the denominator. You started from the bottom, now we're here. And then you add whatever that is in that numerator. So 5 times 1 gave you 5, and 5 plus 4 gave you 9. So our denominator stays the same. It's 9/5. This is going to be a lifesaver if you have larger whole numbers that you're trying to convert your mixed numbers into fractions greater than 1. So we got the same answer. Now let's try that strategy with our second mixed number, which is 3 2/3. So I'm going to rewrite it. We've got 3 2/3, and I'm going to use my started from the bottom strategy. I'm going to multiply our whole number by our denominator because we're showing our wholes, and we're adding what is already there with our fraction. So started from the bottom, now we're here. So 3 times 3 gives me 9, plus 2 gives me 11. Our denominator stays the same, it's 3, 11/3. So now I'm looking at 9/5 times 11/3 fifths. Oh, I'm getting kind of out of the frame here. Let me back up a little. Okay, so I know that 9 times 11 equals 99, and 5 times 3 equals 15. How are we feeling about this? Good? Ooh, what are we noticing about this now? So now I notice that my solution, my product, is a fraction greater than 1. So what if that's not one of my answer choices? What if I'm taking the quiz on this and the answer choices are just mixed numbers? A, B, C, and D, they're all mixed numbers, and I don't know because I have this as my answer. Ugh, I must have solved it wrong. I guess I'm just going to erase everything. No, don't just erase everything and start all over. You're right. What you need to do is you just need to convert your fraction greater than 1 back into a mixed number, and you'll be good to go. So I like to do something called a number bond. And a number bond is where you decompose that improper fraction into parts that are easier to work with. So I'm going to pull my wholes. That's what I call this strategy. Pull your wholes. You're pulling out your whole number, the whole number 1. So if I'm working with 15ths, how can I show one whole with 15ths? That would be if you said 15 15ths, you are correct. So in order to keep track of our original numerator and the wholes that I'm pulling out, I might over here somewhere separate subtract the 15ths that I am subtracting to, keep track of them. So 9 minus 5 would be 4, and 9 minus 1, 90 minus 10 would be 80. So I'm left with 84. Can I take out another whole? Yes. I'm going to subtract another 15 15ths. Regroup. 80 turns into 70. 4 turns into 14. 14 minus 5 gives me 9. 70 minus 10 gives me 60. Can I pull another whole? Yes. So I'm going to subtract the next whole. 60 minus 10 gives me 50. And I'm going to draw that on my number bond model. So I have 1, 2, 3 wholes. That's why I draw the box around them, because these are number ones. I'm going to take away or pull another whole. So I've got 15/15, and I'm subtracting that. 50 turns into 40 and 10 ones. 14 minus 5 leaves me with a 9, and 40 minus 10 is 30. So I've subtracted 1, 2, 3, 4 wholes. Can I take another whole? Yes. Okay, now I've taken 5 wholes. Can I take another one? Can I pull another? Yes. Can I take another hole? Can I pull another hole? No. What am I left with? 9? 9 what? Good job. 9/15. So I'm going to put that piece back up here. That's what I'm left with. So let's rewrite our new mixed number together. So I'm looking at this number bond I just made, and I have 1, 2, 3, 4, 5, 6 wholes. And I'm also left with 9/15. 6 and 9/15 is my product. That's it. It's as easy as that.